I think this is the part 2 of under the chapter 5 numerical solution to differential equation, and I'll be discussing another type of method in solving differential equation, which is the Heun's method. And Heun's method is under modified Euler's method, where we use this as a better version aside from the Euler's method. And I think we should move forward as we consider the ordinary differential equation in the form dy over dx is equals to fx of y, and the last point is x of n and y of n. These are the step-by-step solution of the Heun's method. First is to solve for fx of n and y of n. Next is to solve for xn plus 1 is equals to xn plus h. Next is to solve for predictor, where yn plus 1 is raised to 0 is equals to yn plus h times the function of x of n and y of n. Next is to solve for the value of fx of n plus 1 and y of n plus 1 raised to 0. Next is to solve for the corrector y of n plus 1 is equals to y of n plus increment h over 2 times the summation of f of x of n plus f x of n plus 1 and y of n plus 1 raised to 0. And we should repeat step 1 to 5 until the required value of x is reached. So these are the formula used in finding, and I think we should move forward in solving Excel for you to be able to understand on how this method is to be used. So the same problem we encountered in Euler's method, a civil engineering firm is testing a new smart polymer support column designed to absorb seismic vibration. In a controlled lab environment, the vertical deformation y in millimeters on the polymer over time x is modeled by secant x dy minus y plus 1 dx is equals to 0, where y of 0 is equals to 0.5 mm. We predict the deformation x is equals to 0.5 seconds, where h is equals to 0.05. And before the material reaches its fatigue limit, we predict the deformation at x is equals to 0.5 seconds. So first, we must establish these three: the increment, the original equation, and the function. So of h, it is given from this problem that the h, or the increment, is equals to 0.05, and as well as the original equation, which is the secant x dy minus quantity of y plus 1 times dx is equals to 0. And as we establish f of x and y, we must segregate the value of dy and dx, dy over dx in the other side, and the value of equation or the function in the other side. And to do that, we must transpose the second term, y plus 1 times dx in the other side, so it will be secant x dy is equals to y plus 1 dx. And if we divide both sides by secant x and dx, we will encounter the value of dy over dx is equals to y plus 1 over secant x. And we recall that 1 over secant x is equals to cosine x by a reciprocal identity in trigonometry. And we write y plus 1 times the value of cosine x. So for x of n here, we established that the initial value would be 0, and it is given in this problem that the y of n, or the initial value, or the y of 0 will be 0.5 mm. So up in this column, in the fourth column, it is defined here that we must find the value of fx of n and y sub n. And to establish that, we must do Excel formulas. And by equating the value of y initial, which is 1, plus 1 multiplied by cosine and x. I think that's it. Yes. And the value is 1.5. And for the value of xn plus 1, we will establish the value of xn plus 1 by adding an increment from the original value of x, which is 0. So we will equate 0 plus the increment, which is 0.05, and we must add dollar sign to improve its consistency and lock the value, so we won't encounter any problems in dragging. And in y raised to 0 n plus 1, we establish equating the initial value of y sub n plus the h, which is 0.05, and we must not forget to put dollar sign, and we multiply it with the value of the fx of n, y sub n. So upon putting that, we should consider tapping this D9, and I think that's it for y raised to 0 and plus 1. So we find the value 0.575, and for the value of fx n of 1, n plus 1, and y raised to 0 n plus 1, we will equate or substitute the new value of x n plus 1 and y raised to 0 n plus 1 to the fx of y function. So through equating, we consider that y plus 1 times cosine new value of x, which is 0.05. I think that's it. And for the last column, which is the y sub n plus 1, we must establish a formula. It is a long formula, and we must take it carefully, where y sub n plus 1 is equals to y sub n plus the increment over 2 and the value of these two function. So upon doing that, we equate the value of y sub n plus increment and putting dollar sign into it, and divide it by 2, multiplying it by the value of fx of n plus the value of this one, and I think that's it, 0.5768. And to establish this new one, we will equate this from this E9, and this we will equate this one from the new value of y. Yes, and I think we might drag this one out, or we must carefully drag this one by one, and check it one by one. Yes, and dragging it and check for the value if it is aligned, and this one as well. Yes, and this one as well. Upon checking, and for the last one, so we concluded that the functions are right, and we highlight this one, and as we drag it, we find the value of 0.05 here. So the value of 0.05 upon highlighting is this one. I think I should highlight this. So 0.05 in seconds is equal to 1.422 millimeters. So it solved the problem of a civil engineering firm of a new polymer support, that we concluded that 0. In 0.5 seconds there are 1.42 deformation. Thank you.